Want to improve your coding skills? Have you ever been stuck on a coding problem, unsure of how to proceed? We've all been there. That's why we've put together a selection of 10 coding problems that cover a range of data structures and algorithms. By practicing these problems, you'll not only improve your coding skills, but also deepen your understanding of these crucial concepts. So, are you ready to take your programming skills to the next level? Stay tuned if you want to enhance your coding skills and get a better understanding of data structures and algorithms. Now, let's dive into the first half of the problems. First up, we have the task of reversing a string. Think of it this way: you're given a word and you need to flip it around, so the last letter becomes the first and vice versa. In Java, this can be accomplished by converting the string into an array and then using a loop to reverse the order of the elements. Next, we tackle the concept of factorials. A factorial is the product of an integer and all the integers below it. In our case, we want to write a Java program that calculates the factorial of a given number. This is a great opportunity to use recursion, a method where the solution to a problem depends on solutions to smaller instances of the same problem. Our third problem revolves around palindromes. A palindrome is a word, phrase, number, or other sequence of characters that reads the same forward and backward. We need to create a function that checks if a given string is a palindrome. In Java, we can do this by comparing characters from the beginning and end of the string moving towards the center. Moving on to the Fibonacci series. This is a sequence of numbers in which each number is the sum of the two preceding ones. We aim to print the Fibonacci series up to a given number. This is another excellent opportunity to utilize recursion or iterative loops to solve the problem. Finally, we have the task of finding the largest element in an array. This means we need to traverse the array and compare elements to find the largest one. This is a straightforward task that can be solved using a simple loop and a variable to store the maximum value. By now, you should have a better understanding of how to approach these problems. But we're not done yet. There's more to come. Moving on, let's tackle the next set of problems. We kick off with toSum. The challenge here is to find two numbers in an array that add up to a specific target number. The key to solving this lies in using a hash map. For each number, we check if its complement towards the target exists in the hash map. If it does, we've found our pair. Next up is binary search. Here, we're searching for a specific element in a sorted array. The trick is to repeatedly divide the search interval in half. If the value of the search key is less than the item in the middle of the interval, narrow the interval to the lower half. Otherwise, narrow it to the upper half. Keep doing this until you find your key or the interval is empty. Then we have linked list. Our aim is to implement a singly linked list and write functions to insert, delete, and traverse the list. Remember, a linked list is a linear data structure where each element points to the next. Insertion and deletion operations involve adjusting these pointers accordingly. Our fourth problem is sorting algorithms. We're to implement popular ones such as bubble sort, selection sort, and merge sort. Bubble sort involves repeatedly swapping adjacent elements if they are in the wrong order. Selection sort works by repeatedly finding the minimum element and moving it to the beginning. Merge sort, on the other hand, divides the array into two halves, sorts them separately, and then merges them. Finally, we arrive at tree traversal. Here, we need to implement different traversal methods for a binary tree, such as in-order, pre-order, and post-order. In-order traversal visits the left subtree, the root, and then the right subtree. Pre-order visits the root first, then the left and right subtrees. Post-order visits the left and right subtrees first, and then the root. Great job sticking around. You've now covered a wide range of problems that will help you in your coding journey. So what's the takeaway from all these problems? The key is understanding the problem, then planning the solution, and finally coding it. Each problem we explored today emphasizes a different concept, from reversing a string to tree traversal. Grasping these fundamental DSA concepts is essential for any programmer, and remember, it's okay if you don't get it right the first time. With each attempt, you're growing, you're learning. Remember, practice makes perfect, so keep coding, keep learning, and you'll see yourself improve in no time.